In this video, we're looking at how can we solve logarithmic equations when we have a lot of logarithms. And this one very specifically, something that I noticed that I have logarithms on both sides of my equation, and every single logarithm has the same base. So if we see something like this, logarithms on both sides of your equation, and every single one has the same base, we can actually do something pretty cool. But before we can get to that property, no matter what type of logarithmic equation we're talking about, we always want only one logarithm on each side. So the first thing I'm going to do is use my properties in order to condense. And once again, in order to condensing, we want one log on each side. So looking here on this one, I see addition. Addition tells me I can use the property rule. The product rule. The product rule says that I can do the product of my two arguments when I rewrite this as one log. So this is going to be the log base 4 of 2x times 3. Well, that is 6x. And on this one, I see division. So that tells me I'm going to do the quotient rule, log base 4. That's going to be 36 divided by 2. And 36 divided by 2 is 18. Now, this is where we get to do something really cool. Because each side is just one logarithm. It's just one logarithm, and they have the same base. You can use what we often call the one-to-one property. But really, what we're saying is that if you have log base b of x set equal to log base b of y, their arguments must be equal to each other. X must equal y. So once again, if it's only one logarithm, they have the same base, we can just take their arguments and say those must equal each other. So 6x must equal 18. Super cool, easy tool to use there. We really like that. That allows us to now, once again, using SADMEP, solve for x. It's not much we need to do here. We just need to divide by 6 to give us x equals 3. Once again, a lot of people would stop here, but they can't. We have to check to make sure that the argument is positive. We're going to check every single argument that has an x in it. That one doesn't have an x. That one doesn't have an x. That one doesn't have an x. This one does have an x. So we're going to say that the value 2x must be a positive number. If I plug this in, 2 times 3, well, positive times a positive is a positive number. We're good to go. Give me a little smiley face, and that is my final answer. So once again, I really like these. These are kind of my favorite. Logarithms on both sides of the equation. Condense it down to where it's a singular logarithm. You can only do this if it's a singular logarithm on both sides. But if you have a singular logarithm on both sides, they have the same base. Just set their arguments equal to each other and solve. Don't forget to check that your original equation needs to have positive arguments all the way around, and then you're done.